Hey everybody, welcome to Geometry 2, Section 11.6, Surface Area and Volume of Spheres. By the end of this lesson, you should be able to understand the vocabulary associated with spheres, find the surface area of a sphere, find the volume of a sphere, and find the volume of a sphere given the surface area. So first off, vocabulary. You should know what a sphere is. A sphere is a round, solid figure with every point on its surface equidistant from the center. That's a fancy way of saying ball. Okay, that's all a sphere is. It's just a perfectly round ball. Something you may not know is something called the Great Circle. And the Great Circle is the biggest possible circle created when you pass a plane through a sphere. So basically, the circle created when a plane passes through the center of the sphere. So here you can see a plane being passed through up here, and it creates a small circle. Down here, it's passed through again, makes another small circle. When you pass the plane through the center, it makes the Great Circle. So the equator is an example of the Great Circle, or the prime meridian, or any longitude line that goes all the way around. Those are examples of great circles. Another thing you should know is hemisphere. And hemisphere is basically half of a circle. It says half of a circle. It should say half of a sphere. So you probably know this because the Earth is separated into two hemispheres, the northern hemisphere and the southern hemisphere. So basically, half of a sphere. So let's talk about how to find the surface area of a sphere. If I've got a ball and I need to cover it with either wrapping paper or I'm going to paint it, I need to know how much paint to use. We need to know surface area. So here's the formula for it. Surface area is just 4 pi r squared. Very similar to the area of a circle, except there's a 4 in front of it. I'm not exactly sure why it's 4, it just is. So let's say we have this example here. And the thing I love about spheres and circles and cylinders and cones is they basically have one, maybe two, I guess cylinders and cones have two, dimensions, okay? But a sphere only has one, radius. That's the only dimension it has. So if the radius here is 24, all you got to do is just plug that in. So 4 pi times 24 squared. So 24 squared is 576. Multiply it by 4 pi, and you've got 2,304 pi. So here's where it can get a little bit trickier. What if instead of giving you the radius, what if they gave you the circumference of the Great Circle? So we're still going to use the surface area formula, but we're also going to use the circumference formula. So because the circumference is 13.8 pi, and we know that the circumference is 2 pi r, let's go ahead and just set up that equation. 2 pi r equals 13.8 pi. And we're going to use that to find the radius. So to get the radius by itself, let's divide by 2 pi. And when we do, the pi's cancel out, and 13.8 divided by 2 is 6.9. So now that we know the radius, all we got to do is just plug it into the formula. And so we get 4 pi times 6.9 squared. So 6.9 squared is 47.61. Multiply that by 4, and we've got 190.44 pi. And of course, since we're talking about area, surface area, it's units squared. Okay, so sometimes they make us work a little bit to figure out what the radius is, but nothing too terribly hard. So now let's talk about volume. So the formula for volume of a sphere is 4/3 pi r cubed. So let's use that formula along with the fact that in this sphere, the radius is 8. Let's plug it in. So 4/3 pi 8 cubed. 8 cubed is 512. Multiply that by 4/3, and we get 2,048 pi divided by 3. And I'm fine if you leave it as an improper fraction like that. That's perfectly fine. Matter of fact, that's a lot easier to grade when you do that. If you're doing Math Excel and they say write it as an exact answer, that's what they want. If it says round to the nearest whole number or whatever, then you'd actually have to multiply that by pi and then divide by 3 and get that decimal. Okay, so here we have another sphere, but it doesn't tell us what the radius is. So find the volume of the sphere given that the surface area is 144 pi. All right, so here we go. They're making us work to find what the radius is. So what they do give us is the surface area. So let's take the surface area formula. Let's plug in that 144 pi for the surface area. And now let's go ahead and try to get r all by itself. Let's divide by 4r, and we get 36 equals r squared. And then when we take the square root of that, we just find out that the radius is 6. So we had to do a little bit of work in order to get the radius. But now that we have it, let's plug it into that 4/3 pi r cubed. So that'll become 4/3 pi 6 cubed, which 6 cubed is 216. Multiply that by 4/3, and we get 288 pi. So this is actually one of the types of questions that the people who write math textbooks love to do, because they make you work to figure out what the radius is, and then you just plug it into the formula. So now what I want to do, let's just have a little bit of fun. Let's find the surface area and volume of R2D2. Now, I'm not going to worry about the two legs and then the one little leg up the front, okay? I'm just going to consider R2D2 the hemisphere on the top and then the cylinder. So let's talk about surface area. What I've done is I've kind of looked up blueprints for an R2D2 model online, and here's what I got. So it looks like the radius, let's see, if the diameter is 19, that means the radius is going to be about 9.5 inches. And then the height would be about 28 inches. Okay. Now, I have no idea if those dimensions are accurate to the model that they used on the actual set, but it's what I found online. And everything online is true, right? So now that I have those dimensions, let's go ahead and do surface area. Let's itemize all the surfaces that we see exposed. Okay, so we've got R2D2's dome, which is his the hemisphere. So when we figure this out, we're going to figure out the surface area of the entire sphere and then just take half of it. See, the next piece that I see exposed is the lateral area of the cylinder. And then, now we don't really see it, but we know it's exposed. The very base that R2D2 has beneath them. And we know that's going to be a circular base. So let's go ahead and get some formulas for these three regions that we're going to find. So for the surface area of a sphere, it's 4 pi r squared. However, since it's a hemisphere, we're only taking half of it. So 1/2, 4 pi r squared. Well, half of 4 just makes 2. So that's the formula I'm going to use for the hemisphere of R2D2's dome. The lateral area of the cylinder, that's just 2 pi rh. And the area of that circular base, that's just going to be pi r squared. So now that we know which regions we're talking about, now that we know the formulas for each region, let's plug in what we know. So the radius is 9.5, so let's plug that in. 2 pi times 9.5 squared. Square that 9.5 and you get 90.25. Multiply that by 2, and the surface area of R2D2's dome is 180.5 pi. So let's go ahead and plug that in there. Now let's figure out the lateral area of the cylinder. So we do 2 pi RH, so 2 pi 9.5 times 28. Multiply all that together and we get 532 pi. And lastly, the area of the base, so pi r squared. Let's plug in that 9.5 and we get 90.25 pi. So now that we've found all those surfaces, let's just go ahead and add them all up. So 180.5 pi plus 532 pi plus 90.25 pi, add them all together, and the total surface area minus the legs of R2D2 is 802.75 pi inches squared. Okay? Now let's go ahead and figure out the volume of R2D2, which I always think volume is a lot easier than surface area. So when I talk about the volume, how much space does R2-D2 take up? There's basically two parts. There's the hemisphere for his dome, and then there's the cylinder for his body. So for volume, the formula is 4/3 pi r cubed, but because it's a hemisphere, we're only taking half of that. So half of 4/3 is just 2/3. So 2/3 pi r cubed, and then volume of a cylinder is pi r squared h. So let's go ahead and plug in our numbers. So for the hemisphere, 2/3 pi times 9.5 cubed. That's 2/3 pi times 857.375. Multiply that by 2/3 and we get roughly 571.58 pi. So now let's figure out the volume of that cylinder. So pi 9.5 squared times the 28, and we get pi times 90.25 times 28, which gives us a grand total of 2,527 pi cubic units inside that cylinder. So now we need to go ahead and add those together. And so we get, add that up, 3,098.58 pi. All right. So hopefully that was just a little bit of fun. And I was just kind of showing you maybe it's not so bad to find the area and the volume of a composite figure. But if you guys have any questions, please feel free to let me know. Either email me or ask me in class, and I'll be glad to help you in any way that I can. Hope this lesson found you all right. I will see you guys real soon, so have a good one.